Welcome to EDU World Space.
In this problem, we have a particle moving in an Archimedean spiral defined by the equation r equals 8 times theta feet with a constant angular acceleration of 5 radians per second squared. And what we want to find in this problem are the radial and transverse components of the velocity, which I've gone ahead and written out the equations for here, when the angle is pi over 2 radians and the angular velocity is 4 radians per second. So we can go ahead and solve these equations. If you look at these, we have everything we need here except for r dot, which it can also be written as dr dt. And we have r of theta, so we could find dr d theta, and we have d theta dt. And these actually cancel out. So we can multiply dr d theta times theta dot in order to obtain our expression for r dot. So dr d theta then is just the derivative of 8 theta with respect to theta, which is just 8 feet per radian, which is dimensionless, so we don't really care about it. So then our dot is 8 feet times 4 inverse seconds, which is 24 inverse seconds, or excuse me, times feet, because this is feet per second. So our dot is 24 feet per second, and we have everything else given. So we can go ahead and start plugging things in. So we'll start with UR. This is just r dot. So that's easy. That's 24 feet per second. U theta is going to be the r times theta dot. R of pi over 2, which is what the radius is, or excuse me, what the angle is there. Our radius is going to be 8 times pi over 2, which is 4 pi. So that's going to be 4 pi times 4 feet per second, which is 16 pi feet per second. So 16 pi feet per second for the transverse component of the velocity. And for the acceleration, for the radial component, it's r dot minus r times theta dot squared, which is going to be a r is r dot, so 24 minus r times theta dot squared. So that's 80 times 4 squared, which is going to be, or excuse me, this is not 80. It's 4 pi times 4 squared, which is just 16. We can actually factor an 8 out of here. So 4, 2, so that'll give us 8 times 3 minus, we pulled a 4 out of here and a 2 out of here, so that's another 2 times 4, which is another 8. So 8 pi, and that's feet per second squared. And a theta is going to be r times theta dot dot. So that's 4 pi times 5 plus 2 times r dot theta dot. So 2 times 24 times 4. So that'll give us 4 times pi, or 4 pi times 5. We can pull a 4 out of here to get 4 times 5 pi plus 48 feet per second squared. And that is the solution to all of these. Next, we could sketch these out. We'll find that we'll draw the velocity in green, and 16 pi is going to be greater than 24. So the transverse component will be greater than the radial component by about a factor of 2. That, so that's r theta. So that this is v, and we'll draw the acceleration in blue. This real component is going to be negative, so it's going to be pointing inward, and this is going to be positive, so it's going to be pointing that way. So that'll be something like that, a theta, this for AR, and that for A in total. We can go ahead and move, whoops. I'm not even sure what that is. We can go ahead and move this. We brought a D along with us, but it's okay. Back there. And our graph will look something like this. And that is our solution.